I will now focus on a specific area: industrial design. This field is part of a broader domain known as product design, and the use of a 3D scanner can bring significant benefits, especially for students. Why? Because traditionally, the development of a product, particularly in an academic context, involves creating functional items, products designed for real use. These products often feature technical components and areas meant for user interaction. Examples include a toothbrush, a razor, a toaster, or similar everyday items. Students begin by developing their ideas, typically through an intellectual process. They explore various possibilities within a defined framework to avoid diverging into unrelated directions. Sketching on paper is often the fastest way to capture these ideas, allowing students to quickly visualize their concepts. From there, the process usually follows one of two paths. The traditional approach involves creating orthogonal views, or, in some cases, perspective sketches. The next step is to use CAD tools to develop a 3D model. This stage can be particularly challenging, especially for beginners, as working from perspective sketches often introduces inaccuracies, resulting in a model that might not accurately represent the initial idea. Many students face limitations when translating their concepts into drawings. While some are skilled in visual communication, others struggle to create accurate sketches. As a result, the creative component often diminishes, and the final CAD model frequently diverges significantly from the original vision. These challenges stem from both technical skill gaps and difficulties in using CAD software. While perspective sketches and manual renders are valuable tools for client communication, the focus here is on creating a CAD model efficiently. Students often encounter additional difficulties when working with technical or organic models, as more complex shapes can lead to significant deviations from the original concept due to software or user limitations. To address these issues, I consider the 3D scanner an essential tool. Using suitable materials like modeling clay, students can craft detailed shapes and finalize them for scanning. This workflow simplifies the creation of precise 3D models in CAD software. In consumer products, symmetry is a common feature and can be achieved digitally by designing only half of the model and using CAD tools to mirror the rest. In some cases, even a quarter of the model suffices, depending on the design. Ultimately, integrating CAD tools and 3D scanning technology allows students to explore innovative methods in design and manufacturing. Despite initial technical challenges, these tools bridge the gap between creativity and functionality, enabling more efficient and accurate product development. The final goal is to improve the model, specifically the surface. The mesh can be smoothed, which is a crucial step. Why? Because manually sculpted models naturally have imperfections. Some are exaggerated, while others are closer to being production ready. This depends largely on each student's aptitude with the technique. However, knowing they can correct these errors later, students tend to focus on what matters most. They're not overly concerned about mastering the tools immediately because they know they can address imperfections relatively easily in just a few steps. Why? Because the purpose of the digitized 3D model is to serve as a reference for extracting points. Now imagine a scenario where you have a perspective drawing. What points can you extract from it? Would you place the perspective image in the background of CAD and try to work from there? No, because practically speaking, that is a 2D model. There is no three-dimensional point cloud from which to extract coordinates. This makes it an impractical approach. In contrast, having a 3D model simplifies everything. Some might ask, if we already have a 3D model, why not proceed directly to production? The answer is that the sculpted model created by the student is not functional. It's important to emphasize that the final model must be functional. A common question, likely influenced by internet trends, is why not use photographs in CAD? this isn't really a viable option. Why? Because using photographs of sketches introduces distortions due to optical processes, which compromise accuracy. The ideal approach in such cases is to digitize the sketch using a flatbed scanner. While some distortions can be reduced, the question remains, photographs of what? If you're photographing an existing 3D model, it's far more effective to digitize it with a 3D scanner. For sketches, using a flatbed scanner is more practical. Either way, digitizing the model or sketch with the appropriate scanner ensures the best results. This brings us to a key point: the availability of scanners. If a 3D scanner is unavailable, there's little to be done. Personally, I prefer to bring my own equipment to avoid relying on institutional resources, which may not always be accessible or operational. I understand that having a scanner on hand isn't always feasible. Equipment might be broken, loaned out, or simply unavailable, a common issue. However, this approach greatly facilitates the transition to CAD tools. It helps align the original creative concept with the final result. As different techniques are introduced throughout the process, some elements of the initial vision might get lost. This is normal. Even experienced professionals can struggle with certain aspects of design expression, which leads to simplification or challenges in effectively communicating ideas. This is especially evident in senior designers who work alongside CAD operators. Verbal explanations of shapes are inherently difficult, and a physical model or 3D prototype provides a much clearer way to communicate. The process bridges the gap between the creative mind behind the concept and the technician interpreting the vision. Poor communication often results in products that look very similar, a trend that's increasingly noticeable in consumer goods. This is partly influenced by the CAD tools themselves. Different software imposes different characteristics. Some CAD software tends to produce more geometric, prism-like shapes, while others are better suited for creating organic forms. Then, there are those that successfully bridge both worlds, such as Autodesk Fusion, which stands out with its powerful T-Spline tools, enabling seamless transitions between geometric precision and organic flexibility. The problem arises when the software begins to dictate the design direction, ultimately limiting the potential of the final product. These technological constraints in the design process can dilute the initial creative idea, preventing it from being fully realized. In conclusion, the integration of 3D scanners and CAD tools into the design process bridges the gap between creativity and functionality, empowering both students and professionals to bring their ideas to life with precision. By overcoming traditional challenges like limitations in manual sketching or the constraints of software, we can achieve designs that stay true to the original vision while meeting the technical demands of real-world production. Whether you're a student just starting out or a seasoned designer looking to refine your process, these technologies open up new possibilities, enabling innovative designs that are both unique and functional. Thank you to all my students. Your work is nothing short of amazing. Thank you for watching, and don't forget to like, comment, and subscribe for more insights into the world of design and technology. See you in the next video.